Optimal health for high performers. This is the Health Upgrade Podcast with Dr. Nawaz Habib.
Hello, everybody. Welcome back to the Health Upgrade Podcast. This is Dr. Habib, and I'm here with my co-host, JP Erico.
Good morning.
All right. So today's topic that we are going to be speaking of is something we haven't talked a lot about in a direct form over the episodes of our podcast, but it is a really important topic and very relevant to today, and that is mental health. Specifically today, we're talking about depression and anxiety and how vagus nerve and vagus nerve stimulation are both involved and can be beneficial in treating and supporting those dealing with these particular conditions, these mental health challenges. Why don't we start off talking a little bit about the biochemistry behind depression and anxiety, the fact that neurotransmitters are heavily involved in this, and just kind of lay the groundwork as to what we are looking at when somebody comes into a doctor's office and is diagnosed with one of these conditions.
Sure. And anytime you talk about depression or anxiety, for that matter, you really have to segregate those patients into different groups based on, I like to do it based on what's the cause. So depression has many different causes. Probably the two largest groups would be those people who have depression that's associated with something that happened in their lives, something tragic, something sad, something that was, that left them emotionally scarred or injured, something like the loss of a child, the loss of a spouse, loss of a close friend, loss of money, financial ruin, things like that. Those are what I refer to as sort of more reactive or responsive depression. You're responding to something that happened in the real world that you're contending with, and it left you scarred in a way that left you with this depression. The second is what I would sort of more refer to as an organic depression, where nothing's really going wrong in your life. And in fact, we see it a lot in people who have everything going well in their lives. They're from the outside looking in, you think that they should be happy people, and yet they're not. At the core, I think there's the same underlying biochemistry, but it is two different groups of people, and we have to consider them separately when we talk about them. Again, the biochemistry is similar, but the cause behind it is different. The biochemistry that we're talking about is, as you mentioned, a disruption in neurotransmitter expression or a disruption in neurotransmitter metabolism. And so what do I mean by that? When you express a neurotransmitter, you have enough of it. It's just, is it being released? Is it being used in the synapse correctly? Is it binding to the right receptors? Is it functioning in the way it's supposed to? The other side of it is, are you actually even producing it, or are you getting rid of it too quickly? Is it being drawn up and disposed of quickly? There's enzymes that degrade important neurotransmitters like serotonin and norepinephrine. I mentioned those two neurotransmitters because a lot of the medications that are out there and used today to treat depression are medications that modulate serotonin or norepinephrine. The earlier versions of medications, the very, very first versions of pharmaceutical antidepressants, if you will, actually dealt with those enzymes that I mentioned that break down neurotransmitters. So those are the monoamine oxidases, MAOIs, inhibiting the monoamine oxidase. So again, depression is related to neurotransmitter expression and neurotransmitter metabolism. Generally, people are in agreement that neurotransmitters like serotonin and norepinephrine, to a lesser extent dopamine, are involved in the underlying root cause of depression. So modulating those or figuring out ways to prevent those neurotransmitters from not being present or not functioning properly is a really important way to treat depression. And I think that's generally agreed upon throughout the industry, whether or not you are sort of more traditional Western medicine, pill-centric psychiatrist, or you're more of a holistic approach, an integrative approach. I think that's where there's a lot of overlap. I think people understand that those neurotransmitters are in play, and how to work with those neurotransmitters can really help.
Yeah, no question. It has to do with some sort of imbalance with those neurotransmitters. And I do very much appreciate and agree with the idea of separating those two root causes, whether there was a traumatic incident or an event that took place versus somebody that didn't have that type of traumatic incident. The pathogenesis in terms of how the progression of that condition occurs is biochemically similar, yet there is a particular trigger or cause in one of those avenues. And so it's an important piece to the puzzle when diagnosing or working with somebody that is dealing with this particular type of diagnosis. You mentioned the degradation or the metabolism of these neurotransmitters. And this is a really important area that I think is heavily misunderstood or overlooked when it comes to the neurotransmitter breakdown and how neurotransmitters are utilized and then broken down effectively in the body. Let's talk particularly in this case about serotonin, because the serotonin breakdown pathway has very particular organic acids that we can test for that are very clearly shown to have a relevant play in this neurotransmitter breakdown, particularly kynurenine and or kynurenate and quinolinate. These are breakdown markers of serotonin. Let's talk a little bit about that breakdown pathway and how serotonin breaks down, and what if we have these markers that can be found on urinary organic acid testing, for example, what that is relevant to or what that's showing.
Sure. And actually, before we get to the metabolites, let's go upstream one step, or actually it's technically two steps. And we've talked about this before. Serotonin is produced from the amino acid tryptophan. It's the original amino acid precursor for serotonin. It's one of the pathways. Serotonin production is one of the pathways that that tryptophan can move through as it's metabolized in the cell. So again, you start with tryptophan, and there's two steps, and you have serotonin. The downstream from that, there's two steps, and you get melatonin. We've talked about the importance of melatonin as an antioxidant as well in other episodes. But the alternative pathway, it's actually the pathway that most of the tryptophan in the cell goes through, is the kynurenine pathway that leads down through a series of different metabolites to quinolinic acid as the penultimate metabolite. The final path is actually to NADPH, which is really important as well in the cell. So the ultimate outcome of producing either melatonin on the serotonin pathway or NADPH on the quinolinic acid and kynurenine pathway are both really important. The difference is, and I think you can tell when I explain it this way, the melatonin pathway creates antioxidants or an antioxidant, and the kynurenine pathway that leads through to quinolinic acid, a lot of those are free radical promoters. So you're starting with tryptophan and you end up in two different directions, one that's antioxidant and one that's actually, it turns out to be also pro-inflammatory, but it's pro free radical production and basically damaging tissue and damaging structures within the cell. The reason for that production, and I think as you move up the causation tree, you'll understand why. The reason why the cell is producing kynurenine and the rest of these has to do with, in part, its own defense system. So in a state where the cell is under assault by a microbe or a group of microbes that are attacking the cell, once those microbes get inside the cell, you want to have as inhospitable an environment as possible. You'd like the cell's interior to be deadly to that microbe. And the way to do that is to increase the amount of or maintain a high level of free radical promoters and free radicals and oxidative species reactive oxygen species that can damage the microbes and kill them. That's, of course, dangerous to the cell itself. So the cell needs to maintain a high level of antioxidants around to offset the damage that those free radical promoters and reactive oxygen species are doing, especially in the context of mitochondria. without getting too deep into it, because I think we've just maybe stepped one step a little bit deeper than we wanted to. But at the end of the day, when there's inflammation present in your body, especially in your brain, if there's inflammation present in the form of cytokines that are signaling inflammation, that is a trigger to the cell to increase the amount of production of the free radical promoters and the reactive oxygen species, and to downregulate the production of the antioxidants. That shifts tryptophan metabolism in the direction of kynurenine and away from the production of serotonin. So inflammation, if you sort of take it at the highest level, inflammation blocks serotonin production or inhibits serotonin production. And so, as we said, one of the things that we're looking to do in treating depression is to reduce anything that would be damaging to production of serotonin, or you want to increase the likelihood that serotonin is going to be produced. The way to do that is to downregulate inflammation. I know that's jumping ahead a little bit, but that's one of the really important things to do.
Yeah, and in bringing up inflammation, it becomes a very clear pathway when we have an inflammatory trigger, not just in the central nervous system, but anywhere systemically throughout the body, that upregulates the inflammatory response within the body, which, as you and I have spoken about previously, is mediated by macrophages. And when it comes to the brain in particular, we're talking about microglial cells, microglial activation. Let's talk a little bit about that particular piece to the puzzle when it comes to depression. How activated, how triggered are microglia when it comes to depression, anxiety, these conditions that we consider to be these psychological type issues, but have a biochemical root to them?
Yeah, so it's a really important question. And I think that gets back to the issue of, is your depression reactive to something that happened in the real world, or is it something that's organic? In each case, as we said before, there is a common biochemical pathway, but how did you get that biochemical pathway activated? Stress in life is something that we respond to. And when I say the word stress, most people think of stress as being an emotional thing or a mental thing under mental stress. But stress can be physical, it can be mental, it can be emotional, it can be even just come as a result of the not having enough nutrition, not having enough sleep, not having enough of that sort of base level of Maslow's hierarchy of needs, just not having enough water, for example. Being dehydrated can be an inflammatory trigger, can activate stress responses in the body. And so when I think about those reactive depression patients where there's something happened that caused them to experience an emotional stress or a mental stress or something physically stressful that led to an inflammatory response, it's not only an emotional response at the nervous system level, it's at the immune system level. And so the immune cells in the body are responding to that same emergency feeling that you have, that cognitive or emotional stress also has associated with it an immune response. And so those microglial cells become reactive and become activated, and as a result lead to inflammation that drives that serotonin response. Same way, an organic predisposition or genetic predisposition to depression may exist simply because microglial cells were previously primed to be in that state. We talked previously about epigenetics and how epigenetics can lead to this. So there's what's referred to as intergenerational trauma, where something happened to a parent, specifically usually the mother, because the mother's where the DNA methylation remains. Sperm don't donate a lot of DNA methylation state to the fetus, but maternal intergenerational trauma can lead to a predisposition to depression, a predisposition to this response in children. So it's really important, that old wives' tale or grandmotherly advice of a woman who's pregnant should not be stressed. She shouldn't be under stress. She put her feet up, all that kind of stuff. We never had the scientific understanding of why people would say that. It was just an observation that we thought maybe didn't apply. But it turns out for epigenetic reasons, it actually does apply. So when women are pregnant, they really should try to minimize their stress so that they're not predisposing their children to a host of different problems, not the least of which could be depression and a predisposition to it. Getting back to the issue of depression and specifically how to treat it and how to deal with microglial cells that are activated, there are a variety of ways to downregulate their activation, which should have a positive effect and tend to have a positive effect on depression.
Yeah, we know that the microglia play a very, very important role, likely the most important role, in my opinion, based on managing and supporting all of the cellular functions within the central nervous system, in particular, in the context of what we're talking about. We know that it's involved in supporting neuronal cell death, in neuron formation, synaptic pruning, synaptogenesis, supporting myelin production, phagocytosis of debris and cleaning up just anything that's in and around that shouldn't be there. Microglia play such an important role. And when they are activated because of some form of systemic inflammation or some form of stress or distress that you've very nicely kind of patterned out and said there's multiple areas that we have to look at because the response in the body is the same to stress in every one of those areas. What we do is we're priming these cells to create this very particular area that we are pushing towards a kynurenine and quinoline breakdown, towards that metabolite. So what we're doing is we're priming these cells to push serotonin away from the serotonin-melatonin pathway towards the kynurenine pathway. And what we're doing is we're increasing oxidative damage. We're increasing the risk of breaking down neuronal cell function effectively. And that then predisposes to, if there is a traumatic event, or if there isn't, primarily when there is a traumatic event or something stressful that occurs, we're then primed and very easily able to step into that state where it's diagnosable depression. In a case where we didn't have that particular trigger, this priming event of other inflammatory triggers continuously happening or cumulatively building up over time can push a person who doesn't have that trigger into this depressive state, just biochemically and organically, as you mentioned as well. So it's a really important distinction to just note that there is this same pathway, but the trigger may or may not be the reason why you went into that. There could have just been priming or cumulative stressors that have built up over time, and epigenetic events will play an important role there.
Yeah, two things to focus on what you just said that I really want to harp on or dive into a little bit further. One is that the last point you said about the importance of the fact that you could have a stress that is adding to a predisposition of depression, and that can be something external. It can be something internal. It can even be the recognition. We're an intelligent species. It can simply be the recognition that you are depressed or that you have a diagnosis of depression. That's why it's so important. And this is where I was really overcome by this thought, which is you can't allow a diagnosis of depression to define you. Because the moment you allow it to define you, then it's very difficult to break the cycle, because the definition of being depressed leads to a stress that sort of is a self-fulfilling prophecy. And so we want to make certain that people who have a diagnosis of depression recognize this is not some sort of degenerative, progressive, terminal disorder. This is something that is temporary. It can be treated. It's sometimes something that just happens naturally and goes away, and you will get through it. And if we encourage people this way, I think it's really important. Now, the second piece of what I was, go ahead.
If you don't mind, I want to harp on that moment just for a second there, because I think that's true for not just depression, but for any condition. If we identify as having or being that condition, right? We hear this all the time. I am asthmatic. I am diabetic. I am in menopause. Like, yes, you are in menopause biochemically. Yes, diabetically, like blood sugar is imbalanced, and that is a sign of diabetes. But if you define yourself as having that condition or that condition defining you, then you take on that identity, and that in itself is a stressor that needs to be driven away. So how we speak to ourselves, the words we use about saying that you are dealing with a condition, I think played a really, really important role. And we could do a whole nother episode on that particular topic on how to shift the words that you're using. I have my own issues with this. I need to work on them myself. But we all need to start to identify the words that we're using actually can drive a stress response very, very significantly.
Completely agree. And we should do an episode on that. The other point that you made that I wanted to sort of focus on a little bit was that depression has a variety of comorbid symptoms, if you will. So when you are in a depressed state, when you have, not are depressed, but when you have depression, depression is defined as having biochemically as having less serotonin and as a result having less melatonin, because we talked about the biochemical pathway. Fatigue, both mental and physical fatigue, are associated with depression. Pain is associated with depression. I remember there was an advertisement about mental health, sort of a public service announcement that talked about where does depression hurt? And it was an acknowledgement that associated with depression can oftentimes be sort of chronic, widespread pain. Another is cognitive dysfunction. It's becoming widely recognized that people who are experiencing depression have cognitive dysfunction. They have cognitive challenges. They don't perform intellectually the way they need to. And it's not a function of the fact that they're somehow distracted by something else. It's literally that their brains are not functioning in a way that allows them to learn quickly, remember things properly, and apply learned knowledge effectively. All of those symptoms have causations that are linked to inflammation. And I just want to go through a couple of them quickly. Fatigue, both mental and physical fatigue, is associated with energy level. The fundamental energy unit in your body is ATP. That ATP is formed most efficiently and most effectively in mitochondria. Your mitochondria are the power plants of your cell. In fact, we call metabolic disease because there's a dysfunction of your metabolism inside the cells, inside the mitochondria. What you want to do is you want to produce lots and lots of energy so that your cells have a surplus of that energy to be able to do all the different things that they need to do to both make you healthy and make themselves healthy. When there's inflammation present and there's a reduction in the production of serotonin and melatonin, then you have a breakdown of the mitochondria being able to function properly because they are creating reactive oxygen species along the way. They're a power plant. They're creating all sorts of energy things, and sometimes they generate things that aren't helpful. And those things need to be broken down or degraded. Those are reactive oxygen species. That's why you need the antioxidants. If the antioxidants aren't present, those reactive oxygen species start to cause damage to the mitochondria themselves. And you have oxidative stress, oxidative damage and oxidative stress. That leads to you not producing enough energy. So fatigue is something that's associated with depression because depression is at its heart a breakdown of producing certain neurotransmitters that are really important, and they have downstream effects. Now, also with respect to depression, you have cognitive problems. Cognitive problems are also associated with that metabolic function, but they also are a function of the fact that those microglial cells that we were talking about, microglial cells are involved in learning. They're involved in memory. We think about how is the immune cell in the brain associated with learning? Isn't that just all about neurons? Well, at one level, you're right. It is about neurons. It's about putting those neurons in the right place. Well, who releases the chemotactic factors that allow those new neurons to move into the right place? It's microglial cells. Well, once those neurons are in the right place, how do they make connections? They make connections because of growth factors that are released by, yet again, microglial cells. So the promotion of making those connections is a function of microglial cells. It's when all those connections are made, not all of them are right. How do we know which ones need to stay? How do we know which ones need to be myelinated? Where oligodendrocytes should wrap themselves around and protect and promote synaptic transmission? How do we get those things to do the right, make the right connections and function properly? Microglial cells, when they're in their non-inflamed state. If they're in an inflamed state, they don't do those things. They don't do them properly. They don't do them efficiently. And as a result, you have discombobulated thoughts. You have fragmented connectivity. You have over-connectivity or under-connectivity, and as a result, you can't apply the knowledge that you think you've learned. Yes, you can vaguely remember having experienced that, but it's not connected properly, so you can't use it. Yeah. So that's another thing. The final piece of those symptoms is pain. And pain is something that we experience as a perception of a physical interaction we're having or something happening in our body. When you get burned in your hand doesn't hurt. Your brain is telling you to experience pain because of something that happened to your hand. The pain is not being generated in your hand. The pain is a perception of that in your brain. In fact, a lot of times when you burn yourself, as a perfect example, you don't actually feel the pain right away. You feel a need to withdraw your hand, but the pain doesn't really happen until minutes later when it starts to really ache. You put your finger under the faucet when you burn it on the stove. It doesn't hurt. The water's helping relieve the pain immediately, but later on it's going to hurt. And so it's really something that's happening in your brain. And so the question is, how does your brain decide whether to apply a pain as a perception to a stimulus that's coming in? It does that because in the brain stem, you have, I like to refer to as like a muffler. It's a filter. And as that signal comes in, there's a level of intensity that that signal has to have in order to break through the barrier. That barrier is something that's referred to as descending inhibition. Descending inhibition is like that muffler or the filter or the dampener that sits there and saying, no. If you want this to hurt or be uncomfortable, it's got to get past me. What is that filter made of? It's made of neurotransmitters. Mm-hmm. If you have a high degree of serotonin, norepinephrine, and GABA, those are inhibiting those pain signals from getting through. Those signals from getting through to the areas that would process it as pain. If you have a high degree of glutamate, which is an excitatory neurotransmitter present, then and glutamate is produced prodigiously if there's inflammation present. If there's inflammation present, glutamate is present, the inhibitory neurotransmitters like serotonin aren't being produced properly, and all of a sudden, everything hurts. So again, getting back to how microglial cells are at play here, microglial cells releasing those inflammatory cytokines, being activated into a pro-inflammatory state, disrupts their function in your hippocampus, so you're not learning properly. 2, it's leading to your experiencing of pain and obviously the depression. So across the board, and fatigue, we talked about that as well. So the comorbid symptoms of depression are all still linked back to that same inflammatory trigger.
The explanation that you just gave on descending inhibition is the best I've ever heard. I love it. And it very clearly shows that there is a pathogenesis to those particular symptoms that is linked to the inflammatory process. And when we break down that serotonin, dopamine, and GABA in particular, we can't stop that signal. And so we go into this glutamate being the main excitatory neurotransmitter there that hypes up this experience of pain, that excites those neurons to say we need to send this signal. Just an absolute perfect way to explain that. And I'm sure in a very soon to happen, future episode, we will have Dr. Peter Statz on to talk about chronic pain and how vagus nerve is involved in the inhibition of chronic pain over time.
So thank you for your compliment of how I explained it. I have to give credit to one of the best papers I've read on the subject was written by Olmos, Olmos, back in 2014, I believe. In it, there's a picture. I've said it before. I think this picture that he put into this paper should be right next to the Mona Lisa in the Louvre, or somewhere taped to the wall next to the Sistine Chapel. It's such a beautiful description of how inflammation and specifically microglial release of tumor necrosis factor alpha, which is like that archetypal pro-inflammatory cytokine, how it affects neurons, how it affects astrocytes, how it affects the release of glutamate, how it increases the excitability, what's actually referred to as excitotoxicity, because it actually can end up being deadly to the cells, how there can be an upregulation of glutamate and a downregulation not only of the production of serotonin, the release of serotonin, but also the expression on neurons of the receptors for GABA. So GABA is a great inhibitory neurotransmitter. It's like the primary inhibitory neurotransmitter. It quiets the neurons down. But in order for that GABA to work, there need to be GABA receptors on the neurons. And so what you want is there to be a healthy number of GABA receptors on neurons, so that when the GABA is released, there's a place for it to bind to and it quiets the nerve down. When inflammation is present, the number of GABA receptors gets gobbled up. They're not there anymore. And as a result, the higher level of glutamate that's being released, the higher level of glutamate that's out there in the synaptic junction, et cetera, starts to become more potent, even more potent, because there's nothing blocking. It's like not only stamping your foot down on the gas pedal, but you've cut the brake line. So all of that is wonderful background. And if anybody is really interested, I believe that paper is freely available online. Olmos was the author, Olmos, from 2014, about excitotoxicity and inflammation. Highly recommend people pick it up and read it.
I've got the image right here beside me. I love that image. So yeah, like if you're interested, it's a great read and a very very detailed but very, very clear way to understand the pathway by which this occurs. Let's shift gears now to talk about how the vagus nerve, acetylcholine, and vagus nerve stimulation are involved in not only the suppression of these symptoms, but more so the effectiveness in reducing the pathway by which we lead to these symptoms overall. So let's talk a little bit about that.
Sure. So the company that first introduced vagus nerve stimulation to the world was a company called Cyberonics. They developed an implanted vagus nerve stimulator for the treatment of epilepsy. A couple things about epilepsy that are important is epilepsy has some phenomena that go on with that hyperexcitation seizure response that is similar, phenomenologically similar to other brain activity associated with things like migraines and other pain symptoms. And so it's not surprising that drugs that have been developed for epilepsy have migrated into treating things like migraines and fibromyalgia and other things. So it's epilepsy is sort of has a lot of siblings, if you will, in other conditions, and medications that were originally developed for it have migrated out to do other things. Vagus nerve stimulation is no different. Vagus nerve stimulation was developed to treat epilepsy. It's very effective in doing that because of the fact that the implantable devices require surgery, et cetera, and some other maybe less honorable reasons. Vagus nerve stimulation is sort of reserved for late in the continuum of care. But it's a very effective therapy and very safe. And so as a result of the work that was done to develop it in epilepsy, there were some observations made by the company that did that, by Cyberonics. One of them had to do with obesity. One of them had to do with depression. And so they went after a depression indication, trying to treat refractory depression. And they ultimately got an FDA approval. Now, there are a few things about the development of that product that indication through the FDA that I think are worth mentioning. One, they didn't distinguish between patients who had reactive versus organic depression. And I think your point about looking at the active metabolites in doing a urinalysis and figuring out what neurotransmitter metabolites are present, and actually also, I think, also inflammatory markers, maybe C-reactive protein, high sensitivity C-reactive protein, and other things, might have helped them produce even better results than they did. And again, they produced pretty good results. They got an FDA approval. And so as a result, I think that there were ways that we could have, or they could have, demonstrated that depression was something that vagus nerve stimulation was very effective at. It is effective, it is approved, but I think it would be more widely used if A, it was cheaper, and B, it had data that was more specific and had a better explanation as to why it worked. So that brings me now to, okay, how is vagus nerve stimulation having that effect? Vagus nerve stimulation has the effect because it causes the release of acetylcholine. Acetylcholine is the primary neurotransmitter of the vagus nerve, which is the parasympathetic nervous system. And both in the brain and in multiple other places in the body, that release of acetylcholine is strong. It's a powerful release. There's lots of it. And when it gets released, it binds to certain receptors. And one of the most important receptors in your body for this inflammation pathway is called the alpha-7 nicotinic acetylcholine receptor. It's an acetylcholine receptor, but it actually is the nicotinic version. And so nicotine binds to it. One of the reasons why nicotine, I'm not advocating smoking by any means, but one of the reasons why nicotine has actually demonstrated itself to be anti-inflammatory, if that is true. It has also demonstrated itself to be an anxiolytic. It reduces anxiety. We haven't spent a lot of time talking about anxiety, but everything we've talked about in depression sort of applies to anxiety too. And so binding to that receptor with acetylcholine, I'm not advocating nicotine, but when you bind to that receptor, it has the ability to reduce inflammation. It takes those microglial cells, those immune cells, and shifts them back out of that pro-inflammatory state, that pugilistic state that they're in where they're looking to fight, into a rest, digest, restore, and doing the housekeeping tasks that they're supposed to be doing, promoting the production of serotonin, promoting the production of melatonin, promoting the proper production of energy in mitochondria. It reduces the inflammatory signals to neurons and to astrocytes, that release of TNF alpha that causes glutamate upregulation, that massive increase in hyperexcitation that can lead to pain. It can lead to migraines. It can lead to seizures even. And it upregulates, the vagus nerve stimulation allows an upregulation of GABA receptors. So you see over time how GABA receptor populations rise in people who are on regular use of vagus nerve stimulation.
Yeah, there's no question about it. And we have multiple studies with multiple types of devices, multiple ways to stimulate the vagus nerve, that vagus nerve stimulation plays an important role or is a wonderful way to treat depression symptoms in particular. There's a study that was done, a 5-year observational study by Aronson et al. The study came out in 2017, showing that in major depression, what they did was they had, it was a 5-year observational study. So it was a very long-term study, very in-depth. And what they had was a group that had treatment as usual, as currently provided by the psychiatric departments at different clinics and universities. And then they had an arm that had treatment as usual, but they added the vagus nerve stimulation piece in as well. And what they found was the vagus nerve stimulation arm had a cumulative first-time responder response that was double that of the treatment as usual response over the 5 years. Essentially, the first time people got out of the depressed state, was twice as common in the vagus nerve stimulation group. That also translated to being told that you were in remission. Vagus nerve stimulation was nearly twice as effective in putting people into remission than those that are just going through the treatment as usual arm over a 5-year period. And they had significantly more positive outcomes in response rate, time to response, duration of response, and also experienced reduced mortality and suicidality. Just a really wonderful way to show that we've got treatment as usual that has some benefits, has some great data, but it doesn't clearly have the same level of important positive change that can be created as when you just add in that one other piece, which is vagus nerve stimulation. It was a really, really great study.
Yeah, I'd like to sort of riff on that a little bit more, which is there's another study, not just the Aronson study that you were talking about that came out in 2017, but there was a meta-analysis done by Scott Berry and team. I know the Berry, both he and his father very well. They did a wonderful meta-analysis demonstrating exactly the same kind of results that you demonstrated. But the important thing to remember is that all of this work that you're talking about and that we're talking about right now has been done with implanted devices that are FDA approved only for treatment of people who are medically refractory. So these are the worst of the worst patients. Yeah. These are depression patients who have failed at least 3 other medications. So they've been on SSRIs, SNRIs, MAOIs. They failed those medications. And so to see those type of results where you see literally twice as many people going into remission, twice as many people being successful on a first treatment basis, that's profound. Because if you could imagine that therapy being utilized in a person who isn't what doctors refer to as the train wrecks, the people who have failed so many different medications, it doesn't look like they've got any other treatment modalities. Now, if you could go back to the beginning and say, instead of putting a person on an SSRI with all of the associated, weight gain, libido loss, and cognitive issues that come with those products, if instead of doing that, you could start them on a vagus nerve stimulator right up front, think about the number of patients who might never need to go on a medication or never need to cycle through multiple medications and experience those side effects. That to me is where the real excitement is, because it would be wonderful. Now you say to yourself, yes, but who's going to spend $30,000 and have a surgical implant put in just to avoid taking a pill? Mm-hmm. Well, you know that the world of healthcare isn't necessarily looking to spend the hundreds of billions of dollars to have those kinds of surgeries done. But the good news is that there are now non-invasive ways of doing it. And frankly, there are natural techniques for vagus nerve stimulation that should be tried even before somebody spends any dollars. I mean, deep breathing techniques, meditation, yoga. Now, I would say that a lot of times people who have depression and are experiencing that fatigue or experiencing the cognitive issues or experiencing just the feelings of being depressed might find it difficult to initiate those types of behaviors and to change their habits. It's a challenge. And I'm not belittling that in any way. So I'm not suggesting that that's going to work for everybody. But to the extent that you can, if you're experiencing some depression symptoms, try those natural ways of dealing with it. If you have a problem with that, the good news is there's now non-invasive technologies. Non-invasive technologies, both auricular that stimulate at the ear. There's a branch. It's not technically the vagus nerve, it's the tragus nerve, but it does ultimately activate similar areas in the brain, so it may have the same effects. There are also devices that stimulate the vagus nerve in the neck non-invasively, so you don't have to have the surgery. And instead of spending tens of thousands of dollars, you're spending a couple of $100. And a couple of $100, I think, for me, if I had a family member who was depressed, I would say it's absolutely worthwhile to spend a couple of $100 to see whether or not a natural pathway through electrical stimulation is working versus jumping on a pharmaceutical right away, especially since those pharmaceuticals, forget about the side effects, forget about the fact that they're not necessarily getting to the root cause that we've talked about the inflammation, but they're also difficult to get off.
Yeah.
The cycling time to properly and in a healthy way get off an SSRI can be weeks or even months long.
Yeah.
So if you're having a problem with them, you may have a problem not being on them. So what I would suggest is it's sort of a no-lose proposition. Try the non-invasive vagus nerve stimulation technologies. If the natural pathways are difficult for you to try it, it may be a boost to get you to the point where you can do it naturally. It may just get you through the period that you're in right now. Look to change your diet, look to change your exercise level, look to change things in your life that are triggering you. And you may find that you beat depression all by yourself without any need for drugs.
And that's obviously going to be the goal, right? If you're able to get over these challenges, these symptoms, and really start to feel yourself again, and ideally without having any of the negative sequelae of potentially adding a medication into your regimen, then why not have that option available? Why not go in that direction? I think it's a phenomenal option for a lot of people out there. I think those that are dealing with depression are often simply looking for hope. They're looking for an answer as to why it's happening. They're often looking for hope that what is going wrong can be resolved. And that's true for a lot of chronic conditions, but in particular, when it comes to your mental health and your ability to be hopeful, your ability to look forward, your ability to plan for the future, it really comes into play. So it's a really important condition that needs to be addressed. Any final thoughts on how depression patients or those that are family members or those that are associated with anybody that's dealing with depression can support them by adding this little piece in?
Sure. Beyond going and finding your favorite vagus nerve stimulator out there, non-invasive one, and picking one up for your friend or your family member or loved one, that's easy. I think people can do that. We could certainly suggest some if people want to direct message us or otherwise, that we can certainly suggest some options. But I would say the one aspect of natural vagus nerve stimulation that I was remiss in not talking about just now is social connection.
Mm-hmm.
And unfortunately, a lot of what we're dealing with in life today is damaging our interpersonal connectivity that we're experiencing, whether it was starting with the lockdown or starting with with social media interactions and connectivity through a very, very narrow and I think chokehold medium, which is your smartphone. We're not dealing with our friends and our coworkers and our family members in a way that is really healthy and the way we need to. I think to the extent that you can, if you have a family member or a friend or a loved one who is depressed or that you fear might be depressed, take the time. You're going to benefit from it too. Take the time and go to that person physically and spend time with that person.
Mm-hmm.
I'll tell you, I realize it's an extreme, but suicides don't happen when you're typically around your loved ones. It happens when you're alone. Okay. And so what I would strongly suggest is to get out and be present for that person. Listen to them. Don't tell them they're wrong. It's like walking up to somebody and saying you're fat. Okay. Walking up to somebody and saying you're fat doesn't do anything other than insult that person. What you want to do is go and explain to them, you're a wonderful person. I want to see you live forever. Let's be healthy together. How can we work together? We know that weight loss is something that works better when you do it with somebody else. Be present for that person who's depressed. Be a help. And I think that we ourselves, the people who are not depressed, will gain something from it. because we're also isolated. We're also not spending enough time with one another. So I would encourage people to activate your vagus nerve naturally, simply by being around other people in not a stressful environment, but be in it in a friendly, warm, sensitive way where you're, have a meal together, go to a movie together, go on a walk together. Walking is a wonderful way to walk away. You just literally walk away from your problems. Just go on a walk. I think just one other comment I was going to say is we didn't get a lot of time to talk on this episode about anxiety. And I know we have a wonderful guest coming up where we're going to be talking about PTSD and his research on vagus nerve stimulation and PTSD. And I think that if we did an episode, not just we did the depression episode, we should do an anxiety episode, because there's wonderful evidence out there and data on vagus nerve stimulation in treating anxiety conditions, from social anxiety to OCD to bulimia, and I think it would be a wonderful opportunity and a great trio of episodes.
Yeah, I completely agree, and I know we did kind of go off the deep end on the depression side, but it needed it, and so I'm glad that we were able to. We will definitely have follow-up episodes to this on those particular topics. So, and just to wrap up the point that you had there with social connection and being with others, and you mentioned that point that walking up to somebody and saying you're fat is going to drive more negative energy, more and the words that we use, coming back to the idea of the words that we use when we are in that social space, we need to be more conscious of listening. We need to be more conscious of being compassionate with the words that we use. And we need to start to be more supportive of one another and not identifying them with simple identifiers like you're depressed or you're fat or things like that. And because when we start to learn that people are people first, and they're dealing with struggles, they're dealing with challenges, they're dealing with stressors, when we help them to work through those challenges and stressors, oftentimes those conditions start to disappear. Those symptoms start to go away. And that's because they've created a positive social association with being who they are, rather than dealing with the stressors and the stressors identifying who they are.
And our own challenges, that we may not be depressed, but every human being has some level of stress, some level of non-optimal mood. We find ourselves, we talk about this, you see it when you help other people, especially people that are really in need, you feel better.
Yeah.
You've accomplished something that's probably the most important thing for a human being to accomplish. Making somebody else feel better, making somebody else rise up, helping them meet their potential helps you optimize your health and your mood. So, without getting spiritual, there's a lot of evidence out there that some of the most happy and content people are people who regularly attend religious services. And again, I'm not promoting one religion versus another. And if you're not religious, find another thing that's like that. But being engaged in a social group, especially one, typically religions are positive, not everyone, but they're positive, and that their goal is goodness. So if you engage with a group like that, and listen, it can be a local food bank, it can be a local 4-H or anything, where you're just going out and helping other people, it can be incredibly rewarding. And I think it will make you a better person, and obviously the world around you.
Absolutely. And I don't think we could end on a better point than that. Let's uplift those around us, start listening better, use better words, and support our mental health through whatever means necessary. And this is really, really important going forward. What a wonderful episode. Thank you so much for joining me on this one, JP. We're excited to get this one out to everybody. If you or somebody you know needs this information, and this is really, really important information, particularly in the world that we're living in right now. Please share it with that person. Please let them hear that there is hope. There are answers. There are tools that can be utilized to help them get out of whatever negative state that they are currently in. Please share this information with whoever else so that we can keep going and upgrading the health of those around us. Have a wonderful day, and we'll catch you on the next one.